Today's problem is kth row of Pascal's triangle. This is on Interview Bit as part of their 12-week interview preparation kit. So you can pause the video, go over there, try the problem, come back, and we'll walk through it. So this is defined as an easy problem. Let's see. Google, it says, may ask you this question. Pascal's triangle. Well, I mean, this is the kind of question that probably, if you were more of a junior level person and not so far removed from school, from math classes, you know, it might even be easier than if you were a seasoned professional who hadn't seen Pascal's triangle in decades. The problem description is: given an index k, return the kth row of Pascal's triangle. And it says something a little bit about Pascal's triangle here. I think I have a picture of Pascal's triangle. Yeah. Let's go over here. That's pretty big. Okay. So yeah, Pascal's triangle has a lot of interesting properties, but if you want to generate row after row of Pascal's triangle, what you would need to know is that the first row is just 1, and the second row is just 1, 1. Now, if you have more than 2 rows, you start getting these numbers here in the middle by adding adjacent numbers from the preceding row. So this one is 1, 2, 1. This one is 1, and then we add the 1 and the 2 to get a 3. We add the 2 and the 1 to get a 3, and then we have another 1 over here, and so on. Now, what they say here about Pascal's triangle is that to generate A at C in row R, sum up A at C and A at C minus 1 from the previous row R minus 1. So yeah, that's what we did, is just so if k equals 3, again, first row is 1, second row is 1, 1, and then you start adding the adjacent numbers, 1, 2, 1, 1, 3, 3, 1. You get this. K is 0 base, k equals 0, and it corresponds to the row 1. Now, I couldn't find anywhere on here where it says what the constraint is on A. How big can A be? But it does give us a method signature where we return an array list of integers. So I'm going to assume that none of the numbers is going to get so big that it won't fit in an integer. Then there's also a question of, I mean, as A gets bigger and your formula is to, your algorithm is to generate every row, that is going to become less and less desirable. There's a note down here. Could you optimize your algorithm to use only O of k extra space? Meaning, don't generate the whole triangle down to the row that you want. But if we take this description, this whole description here, sorry I missed part of it, and this here, why does that not start where I think it should? It does suggest that if you did write the algorithm to generate all the rows, that it would pass, that it wouldn't time out. I haven't tried it, okay? But there is another way to do this. One of the properties of Pascal's triangle is in combinatorics. So you've probably seen this notation, N, C, R, sometimes read as N, choose R, meaning how many ways can you choose R things from a group of N things? And it can be written this way. as well. And here's the formula for calculating it: n factorial over r factorial times n minus r factorial. Okay, now if we run r from 0 to n, then what we get here is the nth row of Pascal's triangle. So we could do that. We could write a loop and we could do the computation for Pascal's triangle like that. It's still, as the input A gets bigger, it's still, it's going to be a lot of factorials. So there is actually an even better way to do it, and that is that there's an identity here. Let me get a pen. The identity lets us go from one number to the next number in the Pascal triangle row, or in the combinatorics, without doing more factorials. We just need to do a multiplication. So if we know what n choose r is, and we actually do know for every row that the first element is 1. So we're going to start with that, and then if we go to r plus 1, you can multiply the previous number times, let's see, it would be n minus r over r plus 1. All right, let me erase that and we'll go back to the code. Okay, so we've solved it really at this point. We'll create a row that we're going to generate. We'll set previous to 1 and we'll add 1. That 1 is always the first element of the row in Pascal's triangle. And then we'll do this iteration using that formula, which is that we can compute the next number in the row by taking the previous number and multiplying it times, the notation's a little different here, but in this case it's a minus I over I plus 1. I think over there we wrote it as n minus r over r plus 1, but our notation here is a little bit different. But that is how you move from one element, how you compute one element in a row of Pascal's triangle from the previous element. All right, and then we get the current element, we add that to the row. We set current to previous and we go again. And again, we run I from 0 to a minus 1, return the row, we're done. Let me move this back over and we'll submit it. All right, thanks for watching. If you found this helpful, hit like, subscribe, check out the playlist on the screen to keep ramping up your interview skills. The video description and the pinned comment both have links to more resources, including a free LeetCode patterns cheat sheet. There's only about 15 patterns that handle like 95% of LeetCode type questions. And yeah, you can download that immediately. There's a link to Code and Conquer, which is my complete coding interview prep course, and we'll see you next time.